This is section 2.3, part 2, where we are going to graph an equation and compare it to the equation y equals x. So before we get into actually working on a problem, let's first talk about this equation y equals x right here. This equation is known as the parent function. And I have y equals x graphed here in our xy coordinate plane. And it's our parent function because it's the most basic linear function. All right, all other lines that are graphed in the xy coordinate plane are some version of this parent function. All right, it's just this parent function translated in such a way so it looks differently in the xy coordinate plane. So this is our most basic linear function. And the parent function y equals x carries two properties. The first property you can see is as it's graphed, it passes through the point 0, 0, which is the origin. So it will always pass through the origin. Which is the point 0, 0. The second property is the slope. Looking at this parent function, we can see it goes up 1 over 1, up 1 over 1. So our slope is 1. The slope of the parent function will always be 1, positive 1. The slope is positive 1. Those are the two properties. So knowing that, let's go ahead and we'll scroll down and look at our first problem. All right, so we've got our first problem here. It's y equals 2x plus 1. Our goal is going to be to graph this, and we are going to graph the parent function. So let's first start out by graphing this line. All right, so we're going to look at our y-intercept, and we can see our y-intercept is 1, so I'm going to plot the point at 1, and then from my y-intercept I'm going to move according to what my slope tells me, and my slope is here, which is the same thing as 2 over 1, so it tells me to go up 2, because it's positive, so up 2 and right 1. So I'm going to go up 2, right 1. And remember, all we need are 2 points, and now we can graph a line. So I'm going to take a straight edge, draw a line through these 2 points, and this is my equation y equals 2x plus 1. Next, I'm going to graph my parent function. And if you go back to the properties of the parent function, we know it passes through the origin, so its y-intercept is always going to be at 0, 0. And we know the slope is always positive 1. So we're always going to have a point at 0, 0, and then a second point at 1, 1, because we're going to go up 1 over 1. Now I'll draw a line passing through both of these points. And this is y equals x. I like to label them when I have more than one line in the same coordinate plane, so it's easy to see right when you look at it which line represents which function. Okay. Now the next thing we have to do is compare these two lines. All right, so we're going to have a couple sentences that we're going to write. We're going to write one sentence comparing the y-intercepts, and then a second sentence comparing the slope of each line. So we're going to start out, and let's first look at the y-intercept. We can see the y-intercepts are different. So I can write the graph of y equals 2x plus 1 has a y-intercept of 1, but y equals x has a y-intercept of 0. That's it. All right. One sentence compared the two, showing that there's a difference in the y-intercepts. Again, we can say the graph of y equals 2x plus 1 has a slope of what? What's the slope? We said 2. It's the slope of 2, whereas y equals x has a slope of 1. And we set that up in the property. So two sentences comparing each one, and I'm not just stating that, oh, there's a slope of 2, slope of 1. All right, I'm comparing them, so I'm using comparative words, and we can see, I'll get a different color because I wrote in green. We can see, all right, in the first sentence, I've got a comparative here with the word but, and in the second sentence, I have another comparative with the word whereas. So I'm comparing each of the graphs, all right, the slope and the y-intercept. Let's go down and look at a second one. All right, our second problem is y equals negative 2x. So again, I'm going to want to graph two lines. One line will represent this function, then the second line will represent the parent function. So I've got y equals negative 2x, and then there's no number over here. So we know it's just like having plus 0. So that represents my y-intercept. So I have a y-intercept of 0, and my slope is negative 2, or negative 2 over 1. So I'm going to go down 2, right 1. Now we'll draw a line passing through each point. And then I'm going to graph y equals x, my parent function, which has, again, a y-intercept of 0, but it has a slope of 1. So just by looking at this graph, you can see both equations share the same y-intercept, which is at 0. So I've got the equation here, y equals x, and this equation is y equals negative 2x. So let's write some sentences comparing them. So we can see both of them share a y-intercept. So I'm going to say both graphs share a y-intercept of 0, and the graph y equals negative 2x has a slope of what? It's negative 2, but y equals x has a slope of 1. So two sentences comparing. All right, so I've got a comparative word in both, and then again a comparative word in but. All right, and that's that.